People communicate with one another primarily through combinations of speech, gesture, and gaze. They speak, they look about, they point, they describe things, they make and break eye contact. The Advanced Human Interface Group at the MIT Media Laboratory is working to make it possible for people now to turn to a computer and behave in essentially the same way, to speak, to gesture, to look about, and to be understood. The computer will listen to their words, watch what their hands and eyes are doing, and interpret those actions in context to arrive at an appropriate response, which for a computer is some action in graphics and speech or non-speech sound. The user should not have to wear encumbering devices. For now, though, we use current off-the-shelf technology. For speech, we use discrete word recognition. We look forward to continuous speech recognition and to even smaller microphones. Tracking hands ideally should be by image processing via cameras at a distance. Currently, though, we use the VPL data glove. Finger posture is given by optic fiber loops attached to the glove. The blue space-sensing cube gives position of the hand. For eyes, we use a head-mounted eye tracker. The user looks through a half-silvered mirror while a small camera and infrared LED light source are mounted above and reflect directly into the user's eye. Two features in the image of the eye are detected. The brightest, the highlight from the light source. The darkest, the user's pupil. The center of both of these features can then be used to calculate the orientation of the eye within the head. The motion of the eye is analyzed into fixations, saccades, and blinks. The position of the user's head is tracked using a second space-sensing cube mounted to the eye tracker. The eye data and head data taken together are used to calibrate the eye tracker. After calibration, a three-dimensional vector is computed and can be intersected with the plane of the graphics display. While the future holds less encumbering technologies, these devices let us begin to explore the underlying logic of combining speech, hand, and eye. We have designed a prototype system that supports interaction with a graphics screen through speech, gesture, and looking. It is made up of two basic components. First, on the left display, a map provides the context. It's a firefighting situation with icons representing airplanes, helicopters, trucks, firefighting crews, and fire locations. The second component, as seen on the right display, is the agent. The agent receives data from the map manager about the layout of objects as well as data about the user's actions. The agent then interprets the user's multimodal requests in the context of the map. Now, let's watch an edited version of a live demonstration of a user in a simulated firefighting problem.
Place a green fire truck there.
Creating the new fire truck.
Label that fire truck Delta.
That fire truck is now Delta.
What is the status of that fire?
Since there are 3 fires on the current map, the user's speech input is ambiguous. In order to determine which single fire is being referred to, the agent now draws upon where the user was looking and/or pointing. The agent compares the location of the three fires with the user's input. Here the user both looked and pointed. The red circles showing where he was looking when he said, "that fire," the single blue circle where he pointed. The agent selects Fire 16 as the referent and can now respond with an answer to the user's question.
Fire 16 is out of control.
Move that aircraft to there.
Two references occurred in this command, the first to an aircraft and the second to its new location. That aircraft could mean either the blue one at the lower left or the green one at the upper right. The fixations and pointing gestures that occurred around the time the user said, "that aircraft," are compared to the locations of the two candidate aircraft. In order to resolve the second reference, the new location for the selected aircraft, the agent uses the fixations and gestures that occurred around the time the user said, "to there." By using the attached time information, the agent resolves both references and carries out the requested command.
Moving aircraft Bravo to map coordinates 273 by 237.
Move that helicopter to there.
In this case, the gestures and fixations do not clearly pick out a single candidate. The agent will then ask for more information.
Which one?
The green one.
Moving helicopter Alpha to map coordinates 128 by 941.
Status of the aircraft south of that fire.
Aircraft Alpha is ready.
Remove that fire.
Delete Fire 14.
Yes.
Fire 14 is now removed.
This work on multimodal natural language input doesn't mean we'll throw away the keyboard, the mouse, the trackball, and so forth. Such devices are useful, even essential. The channels of speech, hand, and eye are in addition to such devices, not instead of. However, not everyone is skilled at handling a keyboard, but most people in the world do speak, gesture, and look about. The goal of this research, then, is to widen the means to communicate with computers and to make computing power available to the widest range of people.